The 1918 Nobel Prize for Chemistry is probably the most important Nobel Prize ever awarded. It was given to German scientist Fritz Haber for solving one of the biggest problems humanity has ever faced. His invention is directly responsible for the lives of 4 billion people today. But when he received his prize, many of his peers refused to attend. 2 other Nobel Prize winners rejected their awards in protest, and the New York Times wrote a scathing article about him. He is simultaneously one of the most impactful and tragic scientists of all time. Perhaps more than any other single person, he has shaped the world we live in today. By weight, most of our bodies are made up of oxygen, carbon, and hydrogen. But the 4th most common element is nitrogen. Nitrogen is part of the amino acids that form proteins. It's part of hemoglobin, the compound that carries oxygen in red blood cells, and it's a central component of DNA and RNA. Nitrogen is essential for all life on Earth. We get our nitrogen by eating plants, or animals which have eaten plants, and plants get their nitrogen from the soil. The problem is, if you farm the same soil year after year, you harvest the nitrogen out of it, and eventually there isn't enough nitrogen for healthy plants to grow. They can't produce enough chlorophyll to photosynthesize, which stunts their growth. Their leaves turn yellow, and they are more susceptible to pests and disease. Crucially for farmers, nitrogen deficiency means smaller yields. The way to fix this is to add nitrogen back into the soil. Nitrogen isn't rare, it's common. 78% of the air is nitrogen. But it's in a form that plants and animals can't use. 2 atoms of nitrogen triple bonded together. This bond is one of the strongest in nature. The way to measure the strength of a chemical bond is by the amount of energy that's required to break it. So, to break apart 2 chlorine atoms, for example, would take 2.5 electron volts. To break apart 2 carbons requires 3.8 eV. 2 oxygens, 5.2 eV. But to break apart 2 atoms of nitrogen requires 9.8 electron volts, a tremendous amount of energy. In 1811, Georg Hildebrandt mixed nitrogen and hydrogen in a sealed flask, trying to make ammonia, one of the nitrogen-containing molecules found in guano. When that didn't work, he submerged the flask 300 meters underwater to increase the pressure. And that didn't work either, but he was on the right track. Increasingly sophisticated versions of these experiments were carried out over the following 100 years. All of them failed. So when Fritz Haber became interested in this problem in 1904, he was joining a long line of failed chemists. He was 36 years old, working as a low-level academic at the University of Karlsruhe. His idea was to combine nitrogen and hydrogen not only at high pressure, but also at high temperature, and in the presence of a catalyst, something that lowers the amount of energy required to split diatomic nitrogen. To do this, new experimental apparatus had to be invented. Haber worked tirelessly on this project, building equipment that could tolerate ever higher temperatures and pressures. He also got lucky. At the time, he was moonlighting as a technical consultant for a light bulb manufacturer. So there he had access to lots of really hard-to-find materials, like the element osmium. Osmium is rare. In his day, there was only about 100 kilograms of the refined metal in existence. But the company he worked for was experimenting with using it for filaments in their light bulbs, so they had most of the world's supply. Haber suspected it might make the perfect catalyst, so he brought a sample back to his lab. And there, in the 3rd week of March 1909, Haber placed his sheet of osmium in the pressure chamber. And then he pressurized and heated the nitrogen and hydrogen to 200 atmospheres and 500 degrees Celsius. Under these conditions, the triple bonds broke apart, and nitrogen reacted with hydrogen. Of the total gas mixture, 6% turned into ammonia. When the gas was cooled, 1 milliliter of ammonia dripped out the end of a narrow tube into a beaker. An elated Haber rushed from one lab to another, yelling, "Come on down! There's ammonia!" Germany's biggest chemical company, BASF, commercialized Haber's process. Within 4 years, they had opened a factory in Oppau, producing 5 tons of ammonia per day. People spoke of making bread from the air. With the fertilizer from this industrial process, on the same plot of land, farmers were able to grow 4 times as much food. And as a result, the population of the Earth quadrupled. There's a good chance you owe your life to Haber's invention. The invention made Fritz Haber a wealthy man. He got a promotion, becoming the founding director of the Kaiser Wilhelm Institute for Physical Chemistry in Berlin. He also befriended some of the best scientists of his day, including Max Planck, Max Born, and Albert Einstein. After Einstein separated from his first wife in 1914, he stayed the night at Haber's house. But if Haber was so well regarded, why was he shunned by colleagues when he won the Nobel Prize? Well, it all comes down to what happened in World War I. Only a few months into the war, the German army was already running out of gunpowder and explosives. Ammonium nitrate, besides being an excellent fertilizer, is also an explosive. Haber lobbied to convert the factories using his process to make ammonia for fertilizer to create nitrate for explosives instead. His superiors believed such a conversion to be impossible, but Haber persisted, and soon his chemical process was at the heart of the German war machine. From bread out of the air to bombs out of the air. But Haber thought chemistry could make an even bigger contribution to the war. In December 1914, he witnessed a chemical weapons test. He was unimpressed. Haber believed that he could do better. He set out to make a gas that was deadly at low concentrations and heavier than air, so it would sink into enemy trenches. And after only a few months of work, he zeroed in on chlorine gas. At 6 p.m. on the 22nd of April, with the wind blowing toward the Allied trenches, German troops released 168 tons of chlorine from over 5,000 gas cylinders. The wall of gas advanced across the battlefield. Since chlorine gas is 2.5 times heavier than air, it sank into the trenches of the Allied soldiers. Any soldier that inhaled a lungful of the gas suffered a terrible death. Chlorine irritates the mucous lining of the lungs so violently that they fill with liquid. The soldiers effectively drowned on dry land. Thinking about this story, it would be easy to paint Haber as a villain, or as a hero, for inventing the process used to feed half the world. But another approach is to regard him as irrelevant to the larger story, because someone else would have figured out a way to process nitrogen out of the air, and other scientists were developing chemical weapons. Over the past few centuries, science and technology have improved our lives immeasurably, but they have also given us ever-increasing ways to destroy ourselves. So the real question is, how do we keep increasing our knowledge and control of the natural world without destroying ourselves and everything else on this planet in the process?